All right, thank you all. I know it's been a long day. We were concerned, we had packed this agenda. We couldn't cut anything out, so we just kept, uh, it's kind of like a whip, right? Of sorts, trying to get you. Anyway, enough of that. Uh, my name's Buck Moorhead, by the way. I'm the chair of New York Passive House. Uh, it is my pleasure to introduce our plenary speaker, James Kitchen of the Mass Design Group. Um, Caitlin Taylor of Mass was originally scheduled to present with James. She's unable to make it today, so James is going to be carrying the whole load for Mass. Um, the regenerative metropolis, quite aspirational. We need to get there. This requisite transformation from merely sustainable to regenerative is imperative, a new paradigm. Integrating all facets of our environmental and buildings design and construction within the circularity of the Earth's ecological systems, while simultaneously respecting people, communities, and cultural systems. No small task. Today's packed agenda has hopefully opened eyes and minds in the room to this essential pursuit. Let's collaborate thoughtfully and ingeniously with the Earth and its people. James and the Mass Design Group collaborate beautifully with human societies within the context of the Earth's systems. James is the Director of Engineering and Performance and Provenance at the Abundant Futures Design Lab, one of the core design labs at Mass. James has a background in structural and civil engineering and deep expertise in designing low-carbon buildings, seismic engineering, and designing with non-conventional materials. He is committed to imagining, advocating, and implementing regenerative practices. I've cherry-picked the following from the Mass website. Mass mission: research, build, and advocate for architecture that promotes justice and human dignity. Mass Design Group was founded on the understanding that architecture's influence reaches beyond individual buildings. MASS, acronym, Model of Architecture Serving Society. Beautiful believes that architecture has a critical role to play in supporting communities to confront history, shape narratives, collectively heal, and project new possibilities for the future. MASS believes in expanding access to design that is purposeful, healing, and hopeful. Mass projects move beyond just issues of energy use and efficiency to holistically design the project ecosystem, including an entire supply chain that is sustainable, resilient, and regenerative. Mass works using a One Health design strategy that produces diverse, healthy, and productive habitats for human, animal, and ecological growth. The Abundant Futures Design Lab fosters a just and regenerative future that promotes health and healing for all species. The lab will be a beacon of optimism, showing how we can all exist within the safe operating space of our shared planetary boundaries. I apologize for reading all that, but I felt it was just incredible how great this presentation is to finish our day for me. At least I'm really counting. No pressure, James. But I'm hoping that's the case. But turn it over.
Awesome. Well, thanks so much. It is 5 p.m. on Friday after Climate Week, so yeah, I'll do it. And thanks to everyone that's presented and stuck around. The breadth and depth of knowledge has been really amazing to hear. And I'm sorry that Caitlin can't be with us today. She's gutted, and yeah, she would have brought the enthusiasm that we all need, to be honest. I do have a background in structural and civil engineering. I joined Mass about 8 years ago in the Rwanda office, and I was a pretty confident structural engineer. I knew how to design buildings. Maybe all engineers are confident, I don't know, but I just like came across this like absolutely enormous learning curve where I needed to know how to make the materials as well as specify them, as well as how buildings are actually put together. And this led me down a whole track of investigating materials really deeply, and I discovered a lot of ecological damage that was occurring because of that, like sand dredging and huge amounts of deforestation. And it really like set me on the path that I do now, which is to basically investigate materials and hopefully turn them into something more regenerative than what we've got. And that's my role within MASS. I have a lot of titles. I should probably cull some of them, but I'm director of the Abundant Futures Design Lab, so trying to really implement nature and climate solutions on our projects, but as well as like researching them and advocating for them like this, and also actually sometimes we're lucky enough to turn them into policy. Caitlin, I've known for most of that time at MASS, so I feel like I can represent her work and her perspective quite well still. And she is a farmer and an architect. She lives in Connecticut, and she has a organic vegetable and cut flower farm there. She started farming when she was studying for her graduate degree in architecture. So the words and the way she thinks is really like intertwined in her head, and it's quite amazing to hear. But when she joined at MASS just after I had joined, we were talking about like our industrialized food and material systems, and we realized we were using the same language to describe two completely different systems, and it was quite an eye-opener really. So I'll go through some of those words that we might use to describe those two systems. Degenerative, we've heard the word quite a lot over time, but it basically just means bad. And these industrialized systems can be bad at all scales, and they can be bad for multiple like actors. So they can be bad for people, it can be bad for the climate, it can be bad for ecosystem health. Uniform, we can no longer see the place or that these materials came from, or the people that made them within the materials and the food systems. And we can like build the same building in Arizona as we can in Alberta, and we can eat the same food in Scotland as we can in South Africa. So they are uniform globally. Proprietary, often things are so complicated nowadays that we can really only understand materials and food systems by their performance and warranties, which I think really encourages a risk-adverse industry. And I think if anyone's following the Grenfell Tower like report that came out recently, it's quite damning of architects, because we do not understand our materials properly, and we trust manufacturers to do the right thing. And I think that when you have a relationship with manufacturers, particularly when they're smaller, I think you can do that. But it was clear that Arconic and Kingspan and there's one more, if we're getting another installation one, that we're basically manipulating fire test data. Like when that happens, like we cannot really trust that performance, that warranty that they're giving us. And from a food systems perspective, like who knew you could actually own a seed, like the rawest little thing of life? But people or companies do own seeds, and actually a very few number of companies own the seeds. And they also are very generous because they'll sell you the chemicals that you can spray on those seeds to kill all of the other life around it, so it doesn't have to grow up in a diverse community of other plants. And that comes at an extortionate price. They are both unhealthy. John, Sarah, and Alison often show a slide which says, "You are what you eat, and you are where you live." It is totally true. Like our materials are unhealthy for the frontline communities where they're made. They are unhealthy for the people installing them. They're unhealthy for the people that spend 90% of their time indoors surrounded by them. And our food is unhealthy and addictive. And the obesity and heart disease and for diabetes have skyrocketed because of our poor health, poor nutrition. They're composite. They are made from so many things that we cannot even really tell what they are anymore. The building materials are glued together so tightly they can't even be taken apart. And that means we can't repair them, we can't recycle them, we can't ideally reuse them. And our food systems are like often can only be described by chemists, and they are described, the ingredients in those are numbers. They are not like words. And they're cheap. This has been mentioned a few times. They're too cheap. If you, like, we don't pay the true cost of our food or our materials, and that is the environmental and social costs that come with our industrialized extractive products. I don't know if any of you have ever received a alternative product recommendation from a contractor, and you just look at it and you just be like, how could anything cost that, be that cheap? And your instinct is probably right, it shouldn't be that cheap. And our food prices, our expectations of what food should cost has declined. We think it should be cheaper than it is, but actually has remained very steady price-wise, whilst we've had decades of inflation for other things. So this is like, so those are the words that we've been using, and it's important because these industries, which we consider to be separate and have been brought together today in this room, are so enormous. Like agriculture, or food systems, uses 50% of the habitable land on Earth. It consumes 70% of the fresh water, and it employs 1 billion people a day, the world's biggest employer. And it produces globally about 25% of our greenhouse gas emissions, which is just behind the built environment, luckily, about 35 to 40% of greenhouse gas emissions globally. And the built environment produces a third of all waste. But the big one to me for the built environment is that our industry consumes 50% of all of the materials produced globally. And we produce 100 billion tons of material globally. Like that, you might think that's a big number, but it's not a big number. It's a really, 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 really big number. Like it's the equivalent of an Eiffel Tower every 3 seconds. That's 1 Mississippi, 2 Mississippi, 3 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi. Like how long can we keep going on like that for? Like that doesn't seem like a practical way of doing it. So we might look at this image, which I find actually quite beautiful in a way, which is of global shipping lanes, and think that we've never been more connected than we are today. And in some ways, you're right, we're very, very, very well connected. But actually, I think it's hiding something a little bit different. I think what we sort of now suffer from is systemic separation. And that separation is actually like actively being designed for. It's separation between us and the rest of the living world. It's separation between individuals, like forcing us by telling us we're competing consumers that don't have enough. It's separation between peoples, us and them. And it's separation between non-human life, like forests and farms and monocultures for the sake of efficiency. So when I see this image now, I'm not quite seeing one of connection. I'm actually seeing one of separation. Like I'm seeing one where it's showing us how separated we are from the things that we consume and where they come from. So I think like those connections, they do still exist. They are inevitable. They will always exist. But they are being obscured and sometimes very frayed. And I think that we need to like genuinely think about how do we reweave those connections together before like our society, civilization just completely unravels. And I think like if we're aiming for a future of abundance rather than scarcity, which I hope we all are, it is going to be a future of connectedness and relationships, like one where we are connected and have relationships with human and non-human life, and use that interconnectedness to understand like and help all life to thrive. So this is mass, and we try to do that as best we can, whatever that huge mission is. We are 150 architects, engineers, landscape architects, ecologists, researchers, grant writers, policy writers, filmmakers, photographers, mountain bike crashers, skiers. Those are two of my personal favorites. And we represent over 20 countries across the world with our employees, and we're also a non-profit. I should probably start with that. We're a non-profit design firm. We have an office in Poughkeepsie if you're ever interested in visiting, and in Boston, Santa Fe, and in Kigali, Rwanda. So we split about half of our time between, half of our projects are basically in Africa and half of them are in the US currently. So we've completed over 230 projects since MAS has been around, and that is in over 20 countries as well. So we've worked on projects from public memorials in Alabama to hospitals in Bangladesh to the largest FIA certified building in Massachusetts. And I have taken 2 projects coming up as case studies to try and really represent the metabolism of our food and material systems on a site. And I think that, like, whilst these projects might feel different from maybe what you're used to, hopefully you can see how, if, for instance, we can do it, or we can think about it on a site, we also have to think about it at a city scale, right? How does the metabolism of a city with regards to food and building materials, and how does that relate to the rural communities and land around it? So I'm trying to convey is that by taking this view of the approach and recognizing the interconnectedness between agriculture and construction, that we can unlock possibilities that we can create a positive change for both of them. So this first project is the Rwanda Institute for Conservation Agriculture. Rwanda is a very densely populated country, and it has a growing population. In the 70s, it was 4 million people. About today, it's about 13 million people, and that's going to double by 2050 to 25 million people. The land ratio was quite healthy in the 90s between forest and grassland, and nowadays it's dominated by 80% farmland, and yet still 20% of the people in Rwanda are food insecure. This is what a lot of Rwanda looks like. It's the land of 1,000 hills. So this land is under huge pressure, as well as the ecology, as well as the biosphere, with population growth and poor farming practices. And this is the Rwanda Institute for Conservation Agriculture, otherwise like acronym to RICA. It's a university campus training the next generation of agricultural conservationists. There's 69 buildings on site, and they represent like all of the buildings you might find in a university as well as at a farm. So there's housing, there's student services, there's research facilities, there's milking sheds, there's warehouses for repairing tractors. All sorts of different typologies are on this site. And I've got to mention that this was built on degraded farmland previously, and now you probably wouldn't believe like what it looked like before this, because it sort of looked like what you can see in the background behind the lake there. And in the next 10 years, 1,000 students are going to graduate from this university, and during that time they're going to have grown their own food, they're going to have raised their own livestock, and they're going to have made final food products from all on this site. And it's really a farm to table approach. Like the curriculum was built around this farm to table approach, and most of these students will not actually be they won't actually be farmers. About 30% of them are expected to be farmers in the future, but the rest of them are expected to go into government, they're expected to go into the tech world, they're expected to go into like other industries. And through this curriculum, which Mass like help develop, we want to connect them with the land, so they take this like lessons, these broader lessons that they'll have learned with them into the future. And they're on a site which is 100% off-grid for electricity and water. The electricity is powered by this solar array that you can see sort of in the corner, and the water is taken from the lake, it's treated, it's used, it's drank, and then it's the wastewater is treated and used for irrigation, and I guess returns to the soil of the lake. And we wanted to also, before the students were like ever on site, we wanted to understand, like, could we use that farm to table approach that we were already thinking about with our materials too. And as we were designing the buildings, we were actually like building very localized supply chains for this campus. And those supply chains, sorry, I don't know why the photograph's skewed, but the supply chains were for sustainable timber, for local stone quarried 10 miles away for the foundations, and for Site 1 Earth that is basically excavated from site, made, the blocks and the rammed earth walls are made on site, and then I guess the blocks go into the building, and it's all basically within walking distance. And like earth construction is not new, and I'm delving into this material because it's my favorite material, to be a bit biased, but earth construction is not new. Like, it's the most ancient material we've got, and but most of the buildings in Rwanda are made out of adobe. About 60% of people actually live in adobe homes. When I lived there for 5 years, my home was adobe, but some of them are built very poorly, and you wouldn't build an institutional building out of this material. So we spent a long time refining the mixture, refining the soil, understanding like the land as well as we possibly could as ignorant architects and engineers, and really using a lot of expertise from the local people as well about where do they source their soil for their homes. And this was the first building product I ever made. Like, I think I made probably slightly less than 1,000 of these in the end, but like it was relatively easy. Like, it was like, but it was also a wonderful time, like actually making these. And in the end, we made, and not me personally, people much stronger than me, made 2.5 million blocks for this project. It accounts for 25% of the total building materials by weight of the whole campus, of the buildings at least. And I think like once you can walk a supply chain like that, you can truly understand the impacts of it, without having to really refer to data, even though obviously most of our practice we can't realistically do that, but it connects you to those materials for sure. And so 90%, 96% of the materials were sourced from within Rwanda, which is actually a country smaller than the state of Massachusetts. And this was good for people. It was good for the local people. We had about 90% of the 1,200 people that were employed on site came from the district which the project is situated in. And 35% of the construction budget went to unemployment, went to labor. And so that was like millions of dollars invested in like the communities that surrounded this project. And you could visibly see the impact it was having. Like, I went to site once a week, and by the end of it, like, people had painted their houses, which might sound like a really small thing to us, but it showed a lot of things, I think, and it stuck with me quite a long time. And using these natural, local, low embodied carbon materials, we were able to reduce the upfront emissions of the building by about 60%. And I should state, after all we've been talking about biogenic carbon, this does not include any carbon storage in these numbers, but probably should add that somewhere. And whilst we you can look at it on a building level. We also looked at it on an infrastructure level. And in this case, because it was such an enormous site, the infrastructure actually accounts for more than the embodied carbon of the infrastructure accounts for more than the embodied carbon of the buildings. And that is actually predominantly due to that solar array. I don't know if anyone's looked at data for solar arrays, but it's an enormous amount of emissions associated with them. So another good reason to try and keep your energy down. And then most sites do not have the privilege of doing this, but we were able to plant a 40-hectare savanna woodland for this, which is basically supports the only other remaining savanna woodland outside of national parks in Rwanda. And the carbon sequestration of that is expected to offset the embodied carbon, front embodied carbon of the project by before 2040. And so hopefully, if we can use the term climate positive, it would be climate positive by then. So by shortening those supply chains for food and materials, we were able to connect both farmers and architects with their impacts. And there was one impact that I wasn't expecting from this project, which was a cultural change. I remember when we did the groundbreaking, which was totally ceremonial, like we were way off construction, but like there was a government official there that was horrified to find out that we were building this like prestigious university out of earth. And we thought the project they might force us not to do that. And my guess is they just forgot about it because we just continued. But it's deemed as a poor person's material. Like we might think of earth as being expensive and for Californian wineries, but this is like, it's a poor person's material in Rwanda and probably most of the world. So but I think that like there was a cultural change as like the president of Rwanda opened this project, and you know it's beautiful. So I think there is a cultural perception has changed of the material. We trained quite a few people in how to build rammed earth in this project, and they set up a cooperative, and now they're building luxury hotels in Rwanda out of earth. I think of that what you will, but it's clearly now being thought of as not a poor person's material. So the second project I'll talk about is hopefully a bit closer to home, which is Stone Barn Center for Food and Agriculture. And if anything, their mission is to change cultural perceptions. So Dan Barber is somebody who pioneered something called the third plate. And I mean, it's also a book if you want to read the book, but don't do it when you're hungry. And our aim for this project was to update their sort of aging infrastructure, where it's like kind of even amazing they could do all the cool stuff that they do anyway. And yes, so that they can fulfill their mission, which is to change like cultural perceptions, like dish by dish. And they are based in Tarrytown, New York, which I think is probably about 45 minutes away, so I'm told. And they're a non-profit farm and restaurant. So we've designed them 3 courtyards. The courtyard to the north is for livestock and biofuel, and the courtyard to the south is for their propagation of plants and their fabrication of all the things that need to do on a farm. And there's a courtyard in the middle which is called this innovation courtyard, which is attached to the older buildings. And this is an image of the innovation courtyard. It's where they do all of their research. They are very high-tech research and laboratories associated with this. I learned way too much about the combustibility of flour dust, which is like something you probably don't need to think too much about. And it's, so they can do their research here, they can make their food products, they can also host events. And when we were, again, walking around this site as ignorant architects and engineers, and I don't use the word ignorant as like a bad thing, by the way, I like to learn. So we were walking around their existing buildings, and they have like this root cellar, which you can probably imagine what a root cellar is. It feels a bit like a cave when you go in it. And we were really keen to basically implement that sort of old, ancient, very sensible technology into this project. So we worked with TransSolar, who have an office like locally, to design that for like modern modern day. And this is the fabrication, the lower courtyard, and it's where they fabricate and they propagate their plants. So they propagate plants from like very old seeds, and normally just like a very few handful of seeds, which they have just managed to be like, they've just been given a handful. So, you know, like when one dies, it's like a devastation that that plant did not make it. So it has to be, so it's, again, it's like a very scientific process, not like how I plant. And this building was designed to be as flexible as possible and very, very material efficient for that. And I guess this is probably a conversation for another time, but if you want to learn anything about circularity and like just real ingenuity, go and hang out with farmers. Like they make things out of other things like you would not believe. And this is the upper barnyard. And I never thought when I was designing like skyscrapers in London that I would have 2 barns on my CV, but I do, and I'm proud of it. And this is more or less just a glorified barn, but there is quite a cool thing about this part of the project, which is the winter hay storage. So I think as like designers are very often when we think about seasonally adaptable buildings, operable windows is like what we can get away with. I mean, in the hotel that I'm staying at, my windows don't even open, so that's could be a win sometimes. And in this project, we basically orientated the buildings so that we could store this cold winter hay that would be built up during the autumn. It would be there during the winter and buffer the cold winds for the animals that are inside the shed. And then as the hay is eaten and summer comes along, and it's that like storage is empty of hay and allows the natural cross ventilation. So I mentioned the third plate concept of cuisine, which is that we basically have to shift our meals towards like ecologically driven taste. Like, and that our plates should be delicious reflections of the place that they were made. We need to like understand where things come from and the ecology of the place, the seasons, the farmers, and the soil that made the food. So we took that as like a sort of task to try and think about like what is the third plate of architecture? Like how can we design and build beautiful reflections of the place that acknowledge the ecology of the place, but also the makers and the culture and the community around it. And we've talked a lot about wheat and straw today, so I probably won't go too much into it, but it's one of the really exciting things. They do a lot with wheat. They like to make bread, and it's really delicious bread. And they use ancient varieties of wheat to make it. And the really nice thing, like the symbiotic type thing between the food systems and the material systems, is that wheat has a longer stalk on it, and it makes much better straw-based products. So that what if we could actually have better tasting bread and better buildings? Ooh, oh, my screen's done something weird. Okay, that's cool. What if we took a more fluid systems thinking approach to making our materials and food? Like, what if our construction schedules were dictated by growing seasons again? What if we cared as much about the process as the end result? And what if we knew the provenance of our material and food, where it came from, who made them, how they were made? And what if we valued our food and our materials for all that is embodied in them? Like, I think Caitlin and I like both realized to have like true or bigger impact than we have normally is that we need to like make stronger connections between our, I guess we might say, life cycles when we're talking from LCA terms, like from growers to makers to builders to consumers to users and beyond. And we think there is an opportunity, if not like a necessity, to actually connect agriculture and construction more strongly together. Thank you.
Thank you so much for your presentation. Very inspiring. I'm a fellow architect, so I'm curious about how some of this can translate into more denser environments and some of the challenges you're facing that in North America. I come from India, so I know some of these systems that have moved from what we see here to more glass, more concrete, more steel. So how are you translating some of the learnings into more denser, more economically challenged in terms of time and investments?
Yeah.
Some lessons would be fascinating to hear.
No, totally. I think economically, I mean, your assumption is that those projects were expensive, but they weren't. So I mean, actually, the Stone Barns one wasn't cheap, but the first one was extremely cheap even by Rwandan standards. But your point is totally valid about how do you actually bring that metabolism of food and materials to an urban settlement. And I think that's like it is about understanding our relationship between the city and its like surrounding neighborhood. I think that's much more clear in our minds for agriculture. Like the slow food movement, for instance, like is really keen on actually us understanding like where our food comes from. There's a lot of initiatives, like I'm maybe more familiar with them in Europe, that are trying to see like how would you grow like within a 70-mile radius of your city all of the food that city needs. And so I think like we could totally do the same with food. I think what we are doing is that we work with people that we trust, manufacturers that we trust, like New Frameworks, for instance. They're really amazing. Like, and I think once you can like get close with those manufacturers and you can actually understand, like you can trust them, so you don't have to become the material expert as well, even though that's also fun. But they also have that same like alignment, and I think that's really key to what I've learned of being in the US for only a few years now, is that in Rwanda we basically had to build the supply chains from scratch if we wanted to do something different. And in the US we don't have to do that because they exist. It's just hard for them. And I think it's about finding the people that you can trust to build and to manufacture what you want, and that they are basically also mission aligned. Hope that helps.
Hello. Could you please explain to us in both of these situations how you have designed for both human waste and food waste, and how you've kind of dealt with that in this circularity?
Yeah, I guess farms are really good circular examples, like I think I talked a bit about like farmers making materials, but they are also inherently always thinking about like composting and like basically trying to like also be circular within their system. So I think like we were very much driven by that as already a requirement. There are farmers will require you to have like where are you gonna store and turn your compost, for instance. So that from the farming perspective, like it seemed already embedded. And then the materials perspective, I guess there's some circularity built into the Rwanda Institute for Conservation Agriculture. I think we were thinking about like one of the downsides of using timber in that industry is that it's not structurally like graded, or basically we structurally grade it. And so from a timber perspective, like we realized that they are potentially not going to be, they might need to be changed out every now and then because you actually don't fully know what the material like strength is. So mostly actually from a deflection perspective, but so they're like they're basically all of the trusses in there are like the same. It's the same design for like something like, I don't know how many trusses we made in the end, but that wasn't due to like a deconstruction aspect, but it just happened to be that that is also a good deconstruction like method, right? Like if you want to change out pieces of timber in that truss, then you can like do it easily, but which I guess would also like help you deconstruct the building in the future. But yeah, I don't know if that fully answered your question about circular materials.
So I thought you had a very interesting projects that you worked on, and I noticed it seems you really tried to involve local people, the farmers, looking at what sort of things they do, maybe some of the vernacular architecture and so on. And I was wondering, when you approach a project, how do you go about, what's your mentality when you're trying to look at what the local people do and what they want? And if you do ever have conflicts, if there are conflicts of interest or so on, how do you resolve those? Because in the projects you described, it seems like there was a lot of involvement, but yeah, I'm just curious about that process.
Yeah, totally, conflicts all the time. But your question about like how do we engage, I think is like you just go there open, asking questions, and don't pretend to be the expert and think that you have the answer. You can so often learn from the people there. And I mean, I gave the earth example there as like we basically the local people who build with earth all the time told us what soil was good to build with earth. So we was like, that's great. And then we took it back to a laboratory and it turns out it's really good for building with earth. And I mean, a different example in the Democratic Republic of Congo is that the local people told us that the termite mound was really good for building out of earth. And if you take like a third of the termite mound away, they can rebuild it back without like destroying their population. And these are termite mounds like the size of this room. Like you have no, it's bonkers. But we were learning from the local people and the local people were learning from the termites. It was super interesting. And then we took it to a laboratory and it's really good earth, really good soil for making earth construction, as you might expect. But anyway, I guess going there and asking questions, is the approach.
So one of the challenges that architects are facing is that the historical development of the role of the architect came about by the existence of the architectural drawing that allowed the architect to not be the contractor or the master craftsman on the site, but to be removed. The educational model, Parsons elsewhere, replicates that. Can you talk a little bit about what changes or challenges you've had to do in the role and the definition of the practice of architecture and engineering, and how that impacts the nature of the work you do, namely the drawing work and the communication work, and whether they were the same in both projects or whether they were significantly modified given the kind of structural conditions and the cultural conditions of the different locations?
I guess so the first part is like, I think, well, I've worked in the UK, I've worked in Africa, I've worked in the US, and actually all three places approach like the practice very differently. In Rwanda, we effectively ended up having to, well, we started with architects, and then we realized that we needed engineers, and then we realized we needed structural engineers, then we realized we needed MEP engineers, then we realized we needed geotechnical engineers, and then we realized we needed civil engineers, and then we needed environmental engineers, environmental designers, we needed landscape architects, and then we set up our own building construction firm. And it was basically because like we realized that to actually get what we wanted in the end, we needed to be able to control all aspects of it. And that doesn't mean like we were like just employing our own people. It was just about like being sort of integrated. And that's like seems quite ambitious for like US based architects, but I think that like I as an engineer can have come to the US and I am sort of surprised. I should caveat that we basically only work with non-profit clients who are very fun, like very, very limited funds. So I don't blame them or us necessarily for this, but we basically only engage engineers at DD. And then they only have the fee to do exactly what is drawn, right? They don't push back on any of the designs. That's like my role, is to basically be like, does that make sense? Like, why are we doing that? Is there a better way of doing it? To actually ask the difficult questions so we have a better end project, which I think is like, when we talk about this separation of roles and specialities, I think it's problematic because of those reasons, that you don't have that like expertise to inform the design early on.
All right, this will be our last question.
Yeah, are there tours of the Tarrytown farm? We do an environmental radio show. I'd love to tell our listeners about that farm, that they could go there and see it.
the public can go there. I think you probably have to like arrange it, but it is publicly accessible. Yeah.
Thank you all. Just thanks to our sponsor, NYSERDA. NYSERDA's Early Design Support Program advances case study investigations and knowledge sharing to establish business as usual holistic carbon reduction frameworks for progressive design, construction, and industry practices. And another thank you for Parsons, New School, and the Healthy Materials Lab for this collaboration. Really very much appreciated.
We also want to continue these conversations of how to make a regenerative metropolis a reality, not just stopping the conversation here, but how do we support and also empower our next generation of folks who are very much part of the regenerative future and the movement towards making that real. So yeah, we're excited to announce that New York Passive House is launching a next gen professionals group. So you can scan the QR code. This is to, again, provide support for mostly college students, emerging professionals, but also inclusive to anyone who's interested in exploring a career path in Passive House, which is a building energy standard that focuses on energy efficiency and also quality, health, and comfort for occupants. So our first event is going to be our social in December. So if you're interested, please sign up. We'll have more details following your way. And that'll be just an initial way for us to meet each other within the Next Gen group and talk more about upcoming opportunities. So thank you.